Good day, grade 8. I am your teacher, Marie.
Good day, grade 8. Now we're going to discuss a new topic. Let us enjoy watching while learning.
Parallelism and perpendicularity. Properties of parallel lines cut by a transversal. Parallel lines are discussed in grade 7, but have you ever wondered why opposite sides of most buildings are parallel? By definition, two coplanar lines are said to be parallel if it does not intersect. Parallel line 1 and line 2 are parallel lines. Here are the theorems. If two lines are parallel to same line, then they are parallel to each other. If A parallel to B and B parallel to C, then A parallel to C. Let us consider lines M and N. Line P intersect line M and N at point X and Y. Line P is called the transversals. Transversal is a line that intersects two or more lines in a plane at different points. When a transversal line cuts a pair of lines, certain pair of angles are formed. They are named according to where they are found in the line. Let us try this given example. So the angle 3 and angle 6, another we have angle 4 and angle 5, they are called the alternate interior angle. Alternate interior angles are two interior angles found on different sides of a transversal. And we have angle 1 and angle 8. They are also called as the alternate exterior angle, which means two exterior angles found on different sides of a transversal. We have also the angle of 2 and angle 7, which is an example of alternate exterior angle. And last, we have the corresponding angles. It is a pair of interior and exterior angle found on the same side of the transversal. So example is the angle 1 and angle 5. Another is angle 3 and angle 7. And angle 2 and angle 6. And last, we have the angle 4 and angle 8. So there are all an example of corresponding angles. The pair of angle formed by a pair of line and a transversal are important in proving that a certain pair of line are parallel. There are postulates and theorems developed to help in proving that a pair of line is a parallel. Corresponding angle postulates. If two lines are cut by a transversal and pair of corresponding angle is congruent, then the lines are parallel. Given, let us have this example. Given lines M, N, and P, then angle 1 congruent to angle 3. Let us prove M is parallel to N. So this will be the given picture of the given lines and the transversal. And here is the proof. We have two columns, the statement and the reason. So statement, so we have the angle 1 congruent to angle 3. Reason, it is given in the given example. Then angle 1 and angle 2 form a linear pair. So it is definition of a linear pair. Then angle 1 and angle 2 are supplementary angles. So supplement postulates. Then angle M, the measure of angle 1 and the measure of angle 2 is equal to 180. Definition of the supplementary angles. Similarly, we have the measure of angle 3 plus the measure of the angle 4 is equal to 180 degree. Definition of supplementary angle. So we have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. We have the transitive property of inequality, which means we have formed that the angle 1 and angle 2 is equal to the angle 3 and angle 4. Then we have the angle 2 and the measure of angle 2 is equal to the measure of angle 4. Subtraction property. Then the angle 2 is congruent to angle 4. Definition of congruent angle. Then we have M is parallel to N. So we have proved that M is congruent to N by the use of corresponding angles postulates. Another example, we have line M, N, and P, which also have the given angle 2 is congruent to angle 3. We're going to find if proof, which is M is parallel to N. So here is the proof. We have the statement and reason. Angle 2 is congruent to angle 3 given. Angle 1 congruent to angle 2 vertical angle theorems. Angle 1 is congruent to angle 3 substitutions. Then M is parallel to N that proved by the corresponding angle postulates. Another one is the alternate interior angle theorem. If two lines are cut by a transversal and pair of alternate interior angle is congruent, then the lines are parallel. So another theorem of it is if two lines are cut by transversal, so the interior angle of the same side of the transversal are supplementary, then the lines are parallel. So let us have an example. So given line M, N, and P, angle 3 and angle 5 are supplementary, angle 4 and angle 6 are supplementary. We have to prove which is M is parallel to N. So here is the proof of the given example above. So the statement and the reason. So angle 3 and angle 5 are supplementary given. Angle 3 and angle 4 form a linear pair. Definition of the linear pair. Angle 3 and angle 4 are supplementary. Linear pair postulate. Angle 4 congruent to angle 5. Supplement of the same or equal angle are congruent. So we have M is parallel to N we have proved by the use of alternate interior angle theorem. We have another theorem. If in a plane, if a transversal is perpendicular to two lines, then they are parallel. So let us have an example. Given line X and Y and X are perpendicular to A and Y is perpendicular to A also. So let us prove that X is parallel to Y. Here is the proof of the given example above. We have the statement and reason. So X is perpendicular to A and Y is perpendicular to A. It is given. So angle 1 and angle 2 are right angle. Definition of perpendicular lines. Then angle 1 is congruent to angle 2. All right angles are congruent. Then we have X is parallel to Y by the use of corresponding angle postulate. Another example is M is parallel to N. Transversal P intersect if M measure of angle 4 is 105 degree. Find the measure of the other angle. Given the reason for each angle, so this will be the picture of the given two lines which is parallel and we have the transversal P. So here is the answer. We're going to find all the measure of the alternate exterior angle, alternate interior angle, and the corresponding angles. So we have the measure of angle 8 is 105 degree because it is corresponding angle of angle 4. Next, we have the measure of angle 1. It is 105 degree, which is angle 8 and angle 1 are alternate interior angles. So we have the same measures because they are congruent. Next, angle 5 is equal to 105. So this is the reason we have the angle 4 and angle 5 are alternate interior angles. So they have congruent. So they have the same measures. Next, the measure of angle 3 is equal to 75 degree. So angle 3 is a supplement of angle 5. So just subtracting the measure of angle 5 to 180 degree, we can get the 75 degree. So that will be the measure of angle 3. Next, the measure of angle 6 is 75 degree. If the angle 3 is 75, then we have the measure of angle 6 is 75 also because they are alternate interior angles. Next is the measure of angle 2, which is equal to 75 degree because angle 2 and angle 6 are corresponding angles. So they are congruent. Next, we have the angle 7, or the measure of the angle 7 is equal to 75 degree because angle 3 and angle 7 are also corresponding angles. So they are also congruent. Then we have the same answer. Perpendicular lines. In the figure 9.10, line M is perpendicular to line N. In symbols, M perpendicular to N. Part of two lines M and N are also perpendicular, like line FR perpendicular to line AR, then line ER perpendicular to the line MR, then line MR perpendicular to line AR, then line FR perpendicular to line ER. So here is the meaning of perpendicular lines. Perpendicular lines are two lines that intersect to form a right angle. This definition leads to the theorem that support perpendicular lines. And here is the theorem. So perpendicular are two lines that intersect to form right angles. So let us have this given example. M is perpendicular to N. It forms four right angles. We have angle 1, angle 2, angle 3, and angle 4. They are right angles. Another theorem form, if the angle in the linear pair are congruent, then the lines contained their sides are perpendicular. So this will be the example. So given we have angle 1 and angle 2 are linear pair, so angle 1 congruent to angle 2. We're going to prove A is perpendicular to B. So here is the proof of the given example above. So we have the statement and reason. So angle 1 and angle 2 are lines, linear pair given. Then angle 1 and angle 2 are supplementary by the linear pair postulate. Then the measure of 1 plus the measure of 2, angle 2 is equal to 180 degree. That will be the definition of supplementary. Next, angle 1 congruent to angle 2 given. Then the measure of angle 1 is equal to the measure of angle 2. Definition of congruence. So measure of the angle 1 plus the measure of angle 2 1 is equal to 180 by substituting the given value in the definition of supplementary and the definition of congruence. Next, we have adding the two measure of angle 1 or the measure of angle 1, we have 2 measure of angle 1 is equal to 180. So M, the measure of angle 1 is equal to 90. We have finding the definition. So we divide both sides by 2. Then A is perpendicular to B by the definition of perpendicular. Another theorem in perpendicular, we have the segment has one and only one perpendicular bisector. Another theorem also, we have if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. We have this given example. Angle 1 and angle 2 are complementary. Prove that the line AC is perpendicular to the line CH. So this will be the figures. And here is the proof in the given example above. So we have the statement and reason. So angle 1 and angle 2 are complementary given that the measure of angle 1 plus the measure of angle 2 is equal to 90. That will be the definition of complementary angles. Then the measure of angle ACH is equal to the measure of angle 1 plus the angle 2, which is we have the angle addition postulate. So we're going to add the angle postulates. Then we have M. Then we have the measure of angle ACH, which is equal to 90 by substituting, because we know that the measure of 1 and the measure of angle 2 is equal to 90 by substitution. So we have the measure of angle ACH is equal to 90. So line AC is perpendicular to line CH. That will be the definition of perpendicular. Another example, find the value of x and the angle LOV if line LO perpendicular to line VO. We have also the given measure of angle LOS is equal to x, then the measure of angle SOE is equal to 15, and the measure of angle EOV is equal to 2x. So this will be the figures of the given examples. So here is the solution in that example. So since line LOV is perpendicular to line VO, then it forms a right angle which is equal to 90. So we have x plus 15 plus 2x is equal to 90. That will be the definition of right angle, just adding the angle of the given. Next, we have adding same term, so x plus 2x is 3x is equal to 90 by transforming the positive 15 to the right side, it becomes negative. So we have 90 minus 15. So 3x is equal to 90 minus 15 is 75. Then divided both sides by 3 to make the coefficient of x be 1. So 3x divided by 3 is x. Then 75 divided by 3 is 25. Therefore, the measure of angle LOV is equal to 90 degree. And the measure of angle LOS is equal to x, which x is equal to 25. Then the measure of EOV, which is equal to 2x, so we have 2 times 25 is 50. Therefore, the angle that form is equal to 90.
Thank you. Enjoy watching while learning. This is your teacher, Miss Marimar F. Figalan.